Hello, all the lovely A-levels. This is a PowerPoint on the carbon cycle, both with regards to the actual element cycle as well as the planetary boundary aspect, only regarding oceans. There's a second aspect, and planetary boundaries that I've omitted here. This was literally because one of you felt during the mock exam, component 1 mock, that there was a gap, and rightly so. We did the nitrogen cycle, however, it just got lost somehow. So here we go, catching up time, carbon cycle. I got carried away with the designs a little bit, so I do apologise, my artistic side here coming through. So this is a mock exam question 7, tidy up. At the end I've got the question and the mark scheme with it, again just to go over the whole thing. In the textbook, both is in the second years, the A-level textbook. I've got the page numbers here for you for those 2 parts that I'm working through. Right, you should know key stage 3, key stage 4, that there is a carbon cycle, that we have got an atmospheric carbon dioxide that somehow goes into plants, magic, and it goes into animals and it comes back while we burn things. So that is a basic background I expect you to have. I also expect you to have heard the key term greenhouse effect somewhere, that we've got the atmosphere trapping infrared radiation. How exactly it works I'll get to, but that is background I'm expecting. Language, there are keywords you do need to use, and you do need to use correctly. Combustion instead of burning, both with regards to the fossil fuel as well with regards to biomass burning. The biomass fuels are coming into the planetary boundaries, the part that I'm not discussing, but it is there, so keep that in mind. Deforestation, basically removing a whole lot of forest and plant biomass. Respiration, which is done by all living organisms, as in it is releasing carbon dioxide back into the atmosphere as it is processing those sugars produced in photosynthesis or chemosynthesis. And then photosynthesis, you should know that one as well. Mainly plants, but some protista have got chloroplasts or pigments in them. Removes carbon dioxide from the atmosphere. You need to know the keyword assimilation. So as and when a consumer eats the carbon compounds in a producer in a plant, so basically rabbit eating grass, or fox then eating the rabbit or so on, all the carbon compounds taken in are being assimilated to make their own compounds, to make their own structural compounds, proteins, and so on. Carbon is used in lipids, carbohydrates, proteins, everywhere. Last one, decomposition, and that's mainly fungi and bacteria. They release carbon dioxide back into the atmosphere. Don't forget that they're detrivores as well, but that's more kind of the nitrogen cycle part there. Right, on land, you should be aware we're starting with carbon dioxide. We can start anywhere, but generally we start with the carbon dioxide in the atmosphere. It's taken in by photosynthesis, and then it can actually theoretically go in 4 different ways. The plant itself can respire the own produced carbon compound and releases carbon dioxide back into the atmosphere. It can be eaten and assimilated by a consumer, so whatever bird, rabbit, primary consumer herbivore is eating the plant material, is taking in those carbon compounds, assimilating them into its own organism. The plant can die, in which case it can go 2 ways. That will add up to making 4 in the end. The plant's body or dead parts can either be decomposed or not be decomposed. So look at those 2 options later on, because they've got to do with is there oxygen available or not. Then same thing actually for consumers or for or decomposers. Again, they respire themselves, later on die, and well, it could be eaten as well, isn't it? Or die, get decomposed, or not get decomposed. So now decomposition, you should know from the microunits as well as from eutrophication that we do need oxygen for decomposition to happen. So how did it look like without oxygen? I'm saying did it look like, because much of that in the discussion goes back to a millions of years ago phase. Even today, even with plenty of oxygen in the air as we've got it nowadays, with the 21% that we've got in a wetland, in a swamp, the further down layer, or the layers deep within a stagnant puddle of water, they lack oxygen. So whatever falls in and falls to the ground, let's say it's autumn, the leaves fall in, some twigs are being broken off during a storm, they fall to the bottom, sink, and just stay there. They do not get decomposed. Nothing lives down there anymore. Some sulfur bacteria live down there, but they don't technically decompose. So it just lingers there and stays there. And whatever falls on top of it is helping compaction, sedimentation, and the embedding of that material into the rock cycle. In ancient oceans, before we had the amount of oxygen that we have got available now, the deeper oceans were all anoxic. So whatever fell into them just stayed, didn't decompose, and entered the rock cycle like this. Now, if you've got plankton to start with, that ends up being crude oil. You can find the same elements. You can find microscopic bits that look like plankton in crude oil nowadays before it's being refined. So you can find out that it actually still has that in it. If it was a forest, then it is now coal. You can, in coal, see the markings of what actually used to be the tree rings and so on. So that is known. Now, how does this entire process work in the oceans? Oh, I didn't at this point add that once we've obviously got the crude oil and the fossil fuels, that's stored in a long-term carbon cycle. And yes, we can do combustion, we can burn it, and then release that carbon dioxide again. In the oceans, the whole thing is starting as well with carbon dioxide, but atmospheric carbon dioxide initially dissolves in the ocean water and turns into carbonic acid. You will hear this again when we're discussing heart rate and breathing control, when we do the entire how does hemoglobin work and so on. So when you're looking at the human breathing and circulatory systems, that will come back, the idea of carbonic acid being formed if you've got more carbon dioxide around. Now, it's similar on land. As soon as you've got that carbonic acid, it is taken up by producers. So you're talking algae, you're talking phytoplankton. Phytoplankton is plant plankton. Zooplankton, it would be animal plankton. It then gets consumed. That would be more the zooplankton, or then the little crabs and little fish and so on. They assimilate the carbon compounds, and again, they die, decompose, or die without decomposing. So it's all those four pathways that we've had on land as well. Same thing for the oceanic consumers and decomposers. Now, if the ocean is anoxic, then the plankton becomes crude oil because it doesn't decompose, and you've just got whatever landslide is depositing a layer of sand or silt on top of it and keeps it there. Now, the crude oil can be burned. I have done this here. However, if the oceans do contain plenty of oxygen, decomposition takes place partly, so all these sort of soft parts of plankton, and we're talking about more evolved forms of plankton a bit later on in the evolution of Earth as an entire planet. We've got plankton that now have calcified calcium and magnesium in their exoskeletons. Also, you're talking about small mollusks, you're talking about arthropods, you're talking about fish bones, you're talking about all sorts of organisms. Their skeletons just will then sink again. They decompose, they sediment, they get compressed and become the carbon that we've now got in chalk and marble. This is actually a picture of chalk. This is what is in chalk. That would be a foraminifera and one of the planktons around at the time. For the chemists, a little side note, lime kiln, when you're firing limestone to get to quicklime to then make cement and concrete out of it, that process releases carbon dioxide back into the atmosphere as well. That's not needed for the biology A level, so don't panic about that. So how do humans impact? I've picked that picture comes on a bit later, and again that would be a coral reef that due to ocean acidification has just been deformed and dissolved literally. Okay, so the human impact starts with deforestation. Quick reminder, we do cut down forests not only to make furniture and have firewood, but also to have the land to do farming on it, agricultural purposes. So how does that impact on the carbon cycle? Initially, if you've got less plants about, they cannot do photosynthesis and less carbon dioxide gets removed. The other impact during the practicality of just getting rid of rainforest, much of what's left, and that picture behind it had it there, the stumps of what is being burnt. It is literally a leftover of the plant material that was there, has to either rot or burn to make way for, let's say, a modern cattle farm or whatever it is that you're planting there instead, crops, or soybeans or whatever. So deforestation is two ways in which it's impacting. The key word climate change, be careful when you're answering those questions, because sometimes they hate the word global warming because it's not showing the full picture. The climate change, it's kind of a whole one. So climate change is literally when you are changing the temperatures, you're changing what is actually going on. This is just a diagram to show the correlation. So two graphs that seem to show a similar trend, even though there are issues and outliers on either side. they want to be in your exam mark schemes, they want to be very specific. You need to know the word greenhouse gases. Carbon dioxide is one of them, methane, CFCs, which actually link to the ozone layer as well, but that's a greenhouse gas collection as well, the carbofluorocarbons. Nitrogen oxides, which can be released with fossil fuel burnings, but it's also released from stagnant water in fields, so waterlogged soils. Water vapor, as in just clouds and moisture in the air, that is normal. They are normal greenhouse gases. They then absorb infrared radiation. It's technically not necessarily from the sun, but it's part of what is being re-radiated off the Earth's surface. That then leads to global warming. So don't immediately jump to global warming. They will want to see the greenhouse gas and the greenhouse effect as an in-between step. That's where you need to be a little careful. Don't immediately go global warming. Go via the greenhouse gases and the effect and the infrared radiation. So biology releasing chemistry. The chemistry then is causing a bit of physics in the atmosphere, and then we get the warming. Right, now the greenhouse effect is actually leaving us with a comfortable plus 15. Without any greenhouse gases, we would have minus 20, and it would kind of be, I think we're just within the Goldilocks zone, we're just within the habitable zone, but maybe life only around the equator, not everywhere on the planet. And that wording here is that key wording with the greenhouse effect. The Earth warms up and the sun has heated the Earth. The Earth is re-radiating heat outwards, infrared radiation outwards, which would just dissipate into the empty cold space, but the atmosphere is trapping this slightly lower energy radiation quite well. Okay. Now, as for the effects of it, there's a whole page summing up the effects. I've just tried to put the main bits together here. So ice caps melting, glaciers melting, and therefore a bit more flooding. Careful, much of the flooding comes from literally the huge amounts of water expanding. The oceans are a lot of water. Everything that gets warmer expands. So flooding of coastal and low-lying areas. Weather patterns change. We're talking droughts, floods, warmer, colder phases, ocean currents doing different things than they used to do, and therefore changing local weather patterns. Also, there are global weather patterns. If you've heard of El Nino before, there are global weather patterns that make their way all the way around the planet. They change. Ocean currents change. Fisheries have to change, and so on. Forest fires, it gets drier, they burn more. Desertification, it gets drier in places, and what used to be Sahel, which used to be still kind of desert with a bit of life in it, becomes proper desert. Extinctions happen, ecosystems do collapse. If you're just removing the water and rivers go dry, you're literally removing habitats. Crop belts might have to move, which can be beneficial. It can mean that we can now in Britain grow crops that will grow at warmer temperatures where it wasn't possible to farm those crops earlier. Fishing areas, with moving of ocean currents, those fishing grounds will change. Localized, that means some crop yields may increase. So a bit warmer is good for crops. Sadly, also good for pesticides, because it's warmer for them means that they can repopulate much quicker as well. However, globally, because we're losing so much arable land, food production will be reduced. So how do we work with that and around that? The ocean acidification, that's the one that your question is actually about. If you have more carbon dioxide, there will be more carbonic acid in the atmosphere. More carbonic acid in the oceans, because that carbon dioxide from the atmosphere has dissolved in it. Lower pH means literally coral reefs, the exoskeletons dissolve in the acid. It literally dissolves them. It reduces the effectiveness of fish gills. Right, I'm going to stop the video here because I think about 15 minutes it's going to kill me off. Right, I shall continue on the agricultural practices in a bit.